All right, question 5 asks for a symmetric key for Diffie-Hellman key exchange. So let's go back to the diagram and see how that works. There's actually two ways of computing the symmetric key. The proof in the text showed that Km equals Kr. So I could either compute Km or Kr. Let me compute Km. The first step in computing Km is to compute R, which is mod g to the mp. So I'll do that. Let me write it down so I don't forget. R equals mod g to the m. Okay, once I have R, I can compute the next step, which is K is equal to mod R to the np. So let me go ahead and do that. So the symmetric key K is equal to mod R to the np. All right, so let's go ahead and do that. In this case, my G is 4, my M is 3, and my P is 17. Okay, so to compute that, I'll compute that in a second. Well, I'll compute it down here. Fast way to do that, I can write that as 4 times 4 times 4, 17. Now that's equal to mod of 16 times 4, 17. Now 16 is the same as minus 1, so I could write that as mod of minus 4, 17. Now mod of minus 4, 17 is the same as mod of 17 minus 4, 17, which is equal to 13. All right, then to find K, so this is my R. Then to find K, I'm going to get mod 13 to the n, and P is 17. I'm sorry, but n was equal to 2, so I'll just replace that with a 2. And then you can figure out what that is. I don't remember, but you can figure that out easily. Actually, 13 squared is 169. So that's 169 is 1 less than 170. So that should be the same as minus 1. Minus 1 mod 17 is 16, so it should be 16. All right. Then go to discrete logarithms. What is a discrete logarithm? Remember, we have we have 7 is our number, and we want to solve the equation. 7 is equal to mod 3 to the x 10. That's how you find discrete logarithms. And here you can just do by trial and error. Just try x equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Should be enough. All right, now if I take 3 to the x mod 10, well, this is going to give me 3. This is going to give me 9. Then the next one gives me 27. 27 mod 7 is 10. 10 is 7. 27 mod 10 is 7. Okay, so that's good. Now, how do you get 3 to the 4th? Well, you can do that as 3 cubed times 3 to the 1st. That gives me 21, which is going to give me 1. For this 5, I can do 3 to the 4th times 3 to the 4th, so that's going to give me 3. And then from then on, it's going to repeat. Okay. So if I want the discrete logarithm in Z10, it would just be 3 and 7. But you can also go on. The next one in the sequence would be 11, then 15, and so on. So you could write this, or you could write this. You could write, since the spacing is 4, I could say 4k minus 1, where k is 1, 2, 3, and so on. So that's the answer to 6.